Hi everyone, good evening. Okay, let's start the today's session. Yesterday we discussed about data visualization in Python, right? So we discussed the different components of Matplotlib library. So how do we create a specific figure and how do we add multiple components to it? So quickly let me, okay, so discuss the key components. So one is okay, let me use this one. Okay, so first important thing is you need to create a space for visual. Okay, so you can do it in two ways. One way is using the entire space. Okay, or you can divide the space into parts. Okay, so these are the two methods. First, you need to decide either you are going to use the complete space for your visuals, or you are building. Basically, it's are you building a single plot? Are you building a multiple plots? Okay, based on that, you need to use the methods. So this is straightforward. And if you want to build multiple plots, so there are three methods, right? One is access method, okay, creating the access and specifying the boundaries explicitly. And the other method is subplot function, and the other method is subplot plots. Okay, these are the three. So this subplot is nothing but 2 comma 2 comma 1. Okay, that method we have seen here. This is plt dot, again this is also here we specify how many parts we want to actually divide. So horizontally 3 parts and vertically 3 parts, it automatically creates the accesses for you. Okay, so this is good. So what we are going to do now is we'll discuss about a high level library, that is Seaborn, and we'll get into a case study, okay, using a real time. So whatever the data set we have seen before the banking case study. Okay, we'll take the data, we'll do the complete end-to-end data preparation. Okay, whatever we discussed in the previous classes using pandas, numpy, and visualization, everything. We'll use all of the concepts we learned in the last 3-4 classes, and we will apply them to solve a problem, that is to predict whether a particular customer is going to accept the offer or not. Okay, yeah. So first, let me import important libraries. We need Seaborn, we need Matplotlib, we need pandas, we need numpy. Okay, this is the first step whenever we start working on any project. Okay, we've imported all the libraries. Okay, let us discuss about important important plots we have in Seaborn, and what is the difference between Seaborn versus Matplotlib. Okay, we discussed Matplotlib, and why do we need to use Seaborn? Let us get that inclusion first. Okay, so first of all, Seaborn is a high-level library. It is built on top of the Matplotlib. So when I say high-level library, it uses Matplotlib in the backend. Okay, so it will do all the customization and it will make your life easy. Instead of you writing multiple lines of the code in Matplotlib, you will see eventually. So with only few lines of the code, you will achieve the same result. Okay, let us go ahead and first import some data set. So basically SNS or Seaborn has some default data sets present in its library. Let us use them. So basically it's a restaurant data wherein it has total bill, it has tip amount. So what is the gender of the customer, whether it is a smoker, a day on which he got the tip, time, size of the okay bill, I mean number of people. So is it like a 2 people group or 3 people group? Okay, so first thing we need to do is we need to set the even let's ignore this, we can directly do this also. So let's say I want to, okay, find the relation between total bill and the tip. Let me go ahead, let me build a scatter plot. So the way to do is you need to simply mention x-axis and y-axis data. See how simple this is. So previously for building the same graph, you had to write multiple lines of the code, right? Yesterday we have seen that. Okay. Now simply you need to call the corresponding functions in the SNS library. So you have x-axis, you have y-axis, and what is the data. Suppose let's say, so the beauty of this particular library is you can mention multiple dimensions. So let's say I want to categorize this by smoker. Okay, smoker yes or no. The way to do it is column equal to smoker. Okay, sorry, it's you. Okay, so basically I want to see, so the categorization versus smoker versus non-smoker. So I can do this. Okay, I can categorize them using another dimension. Okay, so like that you have multiple options in scatter plot. Okay, so previously we had to do it everything manually, right? So you need to add a label, you need to use plt dot okay, different options we have, right? We have seen that, right? So especially in matplotlib, is my screen clearly visible to you? Are you facing any issue? Shall I increase the size of the screen? Somebody is saying it's not visible. Everyone, are you able to see my screen clearly? Yeah, I've increased my size. Is it now better? Okay. Okay. Yeah. Cool. Okay. Okay. So this is how you can actually call a single function and you can achieve the same functionality which you otherwise had to write multiple lines of the code in Matplotlib, right? So that is the benefit of using a C1 library. So you can actually set some, okay. So there are a lot of cosmetic, okay, cosmetic options are also available. Like if I set it up, okay, I can change the background. Okay, I can actually play with the different aspects of okay, the visual. So there are so many options available in C1 to change the cosmetics. So previously, if you remember the Matplotlib, it's the basic okay, background, right? So it is very difficult to customize each and every option of the background, especially in Matplotlib. But when it comes to Seaborn, you can simply change with the different options available. So you can simply change it with set underscore style. Okay. Yeah. So we'll discuss about two important things now. Okay, so this is the basic syntax of Cbon. So what we will do is first we'll try to understand how do we integrate Matplotlib functionality with the Cbon. So when I say Matplotlib functionality, so we learned how to divide the total plot space into multiple parts and all using Matplotlib, right? Let us see how do we use the already created objects in the Matplotlib and how do we use them for creating graphs using SNS. So let's take a particular example and okay, let me explain you that you will understand it clearly. So okay, so if I want to create multiple object, let me use subplot method. Let me create into 2, 2 and size equal to should be so first okay, I have so these variables. Let me go ahead and build multiple okay visuals. So let me use this first. You have an option called let me remove this so that no need to scroll that. Okay. Ax equal to axis of 0, 0. Okay. So you can take control of the axis object that is created. Okay, this is one plot. Let me go ahead and create different plots. I think 0, 0, 0. So see, so the way to do it is whenever you are creating a graph, okay, you need to mention which axis object it needs to take. Okay, so if you specify that in Ax argument. So it uses the corresponding argument and it creates those accesses. Okay. So this is one way of integrating the matplotlib objects we have created using plt.subplots method, or you can actually replicate this with any of the methods we have discussed. Like instead of plt.subplots, you can actually go ahead and create a subplot to do one. So you can also use this method. Okay, any method you can use. Okay, so ultimately the intuition is so matplotlib is the backend for a Seaborn. So that's why whenever you are using Seaborn, you can always take control of the matplotlib in the backend. Okay, so this is one way of taking the control of that. And suppose let's say you don't want to use matplot method. So what are the alternate methods available in Seaborn itself? Let's try to see them. Okay, yeah. Okay, we have these steps. Just a minute. Okay, first you need to create SNS object equal to SNS dot. Okay, you have something called facet grid. The first argument is you need to mention the dataset name and you need to mention what is the variable it needs to use to divide the complete space. So if you see, so it is dividing the space into two parts because the reason being, okay, if you see tips of time, it has two unique values. So one is dinner, another is lunch. So we want to see the effect, okay, effect of tips over these two time periods. So first we divided the complete space into two parts. Now the next thing we need to do is we need to map the corresponding visual to the object. Okay, so the way to do it is, first we need to use the function called dot map, and in that the first argument is the visualization we need to map. Okay, so suppose let's say I want to map plot. So see, so this is the distribution of okay, tips across lunch and dinner. Okay, KD plot is nothing but kernel distribution. Okay, kernel density estimation plots. So that is nothing but histogram with a smooth curve. Okay, you can think of okay, if you divide your x-axis into multiple fine bins. Okay, in such a way that okay, you will get a smooth line. So that is nothing but okay, it is a distribution okay plot. That is nothing but kernel density estimation plot. Okay, so what we are seeing is the distribution of tips across lunch and dinner, but the main takeaway from this particular method is we are not specifying any subplots or how many subplots it needs to okay build, etc. So we are just specifying the data set it needs to take, and we are just specifying the column, okay, the column which it needs to take for okay, breaking down the entire space into parts. So the number of parts will depend on the number of unique values present in this column. As the column has two unique values, time and lunch, okay, sorry, lunch and dinner, okay, divided it into two parts. Then the second step is you need to map the corresponding visualization, whether it is a KD plot or bar plot or box plot, that doesn't matter. So ultimately the architecture you try to understand. So what we are doing, we are first creating an object and we are mapping a visual to that object. So that's it. Okay, that is the intuition you need to get. So this is one way of doing thing. That is, you explicitly specify how many plots you need to have, etc. But using Seaborn, you have the flexibility of specifying that column. Okay. Hope the difference is clear. Everyone. Yes, to answer your question, yes, somebody is asking, can we use dual by axis in SNS like matplotlib? Yes, yes. Whatever we did yesterday. So let me get that example for you. Yes. Okay, so what you need to do is instead of plotting access to dot plot here, you can use SNS. Okay, you can use SNS dot plot and AX equal to access to. Okay, that way you will get the same result. It's the same concept. Basically, what's happening is, so the underlying matplotlib objects will remain same. So you are just enhancing the functionality using one more high level library. Okay, so you can always use all the matplotlib functions, methods, objects, everything you can use in Seaborn. Okay, cool. So then So we have, okay, something called, okay, we have some more important plots for what do you say, pairwise relationships. Let us go ahead and let's use that using one more data set. Let me know. Let me import iris data. Okay. The first thing what I need to do is I need to create again SNS object equal to SNS dot. Previously, I have created a facet grid. Okay. So this grid, which will take a variable and based on that, it will divide it into multiple parts. So I have one more grid available, which is pair grid. I just need to mention the whole data set. So if you see the difference here, I am mentioning the columns. Okay. Here, I just need to mention the entire data set. So what happens is it takes all the variables and it maps it accordingly. So let me create SNS object dot, again the same thing. It has the map function. So SNS dot. So what is the function I want to map? Okay, let's say I want to map scatter plot. Okay, I want to understand the relationship between multiple variables present in this iris data set. Okay, so if you see first, this one just ignore. This is just, anyway, I can do this here. I just loaded the data set. Okay, if you see, there are only two steps. The first thing is I need to mention the grid type. So that is here pair grid. Okay, and the data set I am taking for the pair grid is iris. So this object is set for me. So let me first only execute this. Sorry, I think I used iris data. If you see, automatically it created the entire space for you. So if you see, so I have four variables in iris data. One is sepal length, sepal width, petal length, and petal width. Okay, 4 into 4, 16 graphs. Okay, 16 graphs were automatically created for me. So that is the beauty of pair grid. So somebody is asking me, can we get the data sets to work with in Python? So these are all default data sets. So once you install Seaborn, okay, once you install Seaborn, so if you don't know how to install Seaborn, so what you need to do is, okay, install Seaborn. So this is the command you need to use if you don't have Seaborn installed in it in your system. So once you install Seaborn, automatically these data sets are present by default. Okay. The function, the method used to load a particular data set is this sns.load underscore dataset. And if you want to know all the data sets present, there is a get data set names. Okay. So you have these data sets present in this Seaborn library already. So you have Titanic dataset, you have tips, you have planets, you have penguins, so many datasets are present. So you have MPG, which is nothing but a mileage of different cars with respect to their characteristics like horsepower, their number of cylinders, etc. You can explore these datasets and you can use this for your data analysis. Okay. There is no need to explicitly get these Excel files or flat files. Okay, SNS library automatically provides these datasets for you. Okay, now let me, first thing is, first I have created a space for this particular data set. Let me go ahead and create a scatter plot of all these variables. So this is how you can actually go ahead and try to see if there is any relationship between two variables. So the diagonal is nothing but the same variable, right? So that's why everything is perfectly correlated. Okay. So this is okay, pair grid, and you have some flexibility in changing some characteristics of all these what do you say, a different individual visualizations. You can change them to histograms, you can change them to scatter plot. Let me do that for you. So first thing is, the first thing remains common, and once the object is created, okay, you can take control of either a diagonal or of the diagonal. Okay, so previously what we have done is we have mapped the entire space, right? Instead of that, what you can do is, okay, it's the SMS dot scatter plot underscore object map. Okay. There's some issue. Let me check this. Tab will not work anyway. Yes. Sometimes what happens is version to version. So once these packages are updated, okay, the options will change. I think these are okay. So basically, if you want to map upper, you can map using upper. Next, you have something called map lower. And let's start carry plot. Okay. Likewise, you can take the control of either upper portion or lower portion, something like this. And you have one more important, one more important method, especially here. So there is something called a pair plot. If you don't want to specify, grid and okay, specify which type of visualization to use, etc. So what you can do is you can use something called sns.pairplot, which we use quite an often okay, in data science. Okay, simple single line. It will give you the complete picture of a data set. Okay, you don't need to specify grid. You don't need to specify which type of okay, visualization to use. It automatically figures that for you. So here I have 4 different variables. I have these on diagonal. I have the distributions of how that variable is, and so elsewhere we have the relationship between 2 variables. So you can see if most of them falls on the diagonal. So like we see petal length and petal width are highly correlated. Okay, and sepal length and petal width, okay, somewhat correlated. Okay, like that you can actually understand how they are correlated, and basis you can take some decisions on keeping that variable or dropping the variable for further analysis. Okay. Let us go ahead and see some of the okay visualizations we can develop, cool visualizations we can develop using Seaborn. So SNS dot distribution plot. I need to mention so which data set shall we take? Let's take so it takes only one argument because it's a distribution. Okay, this is the distribution plot. So the way to create is, so when I say distribution plot, so it creates so if you remember our discussion on matplotlib yesterday, so the way to achieve the same in matplotlib is you first need to create x and you need to mention the bins, right? If you remember yesterday, let me show you that the same thing which we had to, if we had to develop this in the bins. Yeah, so see, first we need to mention x, then we need to mention the bins. Okay, how do we want to create the bins, etc. So we had to write all that code, right? So here it automatically does that for you with simple use of dist plot. Suppose let's say I want to create a bar plot. Okay, simply I need to mention x. Let me take tips data set. X axis, let's say I want to count uh, Okay, this is how we can simply mention x-axis, y-axis, and the corresponding data to it. Okay. Suppose if I want to create joint plots, okay, this is one of the coolest visualization in Seaborn. Let us go ahead and see how do we create joint plots. Okay, so SNS dot joint plot. You need to mention x-axis. Let's say x-axis equal to simple underscore weight, and y-axis equal to underscore length, and data is underscore data. Okay, so let's see what exactly is this joint plot. So it combines two different plots. Okay, so if you see, the major plot is scatter plot. So this is required to see the relationship between two variables. Okay, and if you see these histograms above and to the right side, so these are nothing but the distribution of sepal length. You can clearly see the distribution of sepal length here, and on the right side you can clearly see the distribution of sepal width. Okay, so without this, I mean, if you want to understand how this particular sepal length is distributed, okay, so you can see that the majority of values are lying on okay, the majority width is okay 3, and there is a right tail. So this is how they're distributed. And if you see sepal length, most of the values are around 6, okay, something like that. So you want to understand, so this is something called univariate statistics and bivariate statistics. If you want to understand one variable at a time, that is univariate, you will do it using the histograms or KDE plots. And if you want to understand the relationship between the two variables, so scatter plots comes into picture. So this joint plot especially helps you to take control of univariate and bivariate using only one particular function, that is joint plot. Okay. Hope the concept is clear, everyone. And let us go ahead and see box plots and violin plots. SMS dot box plot. Again, here it's the same thing. Suppose, let's say I want to see by each day what is the distribution of tips. Equal to tip. Let me first see if I am variable names or not. Okay, here is tips. This is tip. This is day. So this is giving a very nice story, right? So if you see on Thursday and Friday, okay, so typically on weekends, your distribution is skewed towards okay, skewed towards the upside, right? So especially on Saturday, you can see a lot of outliers. Like I said before, these outliers are the data points. So these are calculated based on the formula that is nothing but Q3 plus 1.5 into IQR, that is interquartile range. Interquartile range is nothing but this side, the length of the, okay, the length of the box present in the middle. Okay, if you see, there are so many outliers present in Saturday. So typically during the weekends, they are giving the tips which are okay, which are not normal. So typically, if you see the middle line, which is nothing but the median. So on Saturday, okay, it is around 3, but sometimes people are getting tips around 6, 8, 10. These are like outliers. This is not a common thing, but sometimes it is happening. So that's why it is called outlier. Okay. So that's how you can go ahead and see, okay, if there are any outliers in the data or not using box plots. So same kind of a story represented in a different format, that is nothing but, okay, violin plot. So violin plot, so it is a visualization wherein it combines box plot as well as, okay, as well as KDE plot. Okay, or you can think of it's a distribution plot, right? Like we have shown you here. So this is okay, this is a distribution plot, right? The line you are seeing is KDE plot. Okay, so think of two KDE plots, distribution plots, okay, attached together. If you just break this violin into two parts, each one of it is nothing but the distribution plot, right? Okay, two distribution plots added side by side, and in between and in center of that distribution plot, they have added box plot. Okay, so what happens is you can see the actual distribution as well as the power of box plot. Okay, you can see there are outliers in it. There is a long tail here, so there are outliers in it, and you can see the actual distribution, how this is distributed across Saturday, across Sunday. You can see how frequent alongside maybe um, let's say at $2, so what is the frequency? $4, what is the frequency? Okay, wow, what is the median of this data? Everything you can see it in one particular graph. Okay, so let us go ahead and okay, let us go ahead and see some of the other important plots, especially heat maps and all. How do we create in uh, SN Seaborn? So basically, heat maps are especially useful when you have multiple data points and you want to see the distribution of them. Let us go ahead and okay, build heat maps. So first, for building heat maps, let us use, sorry, SNS dot load dataset. So this is flights. Now I have flights. Let me see whether it is imported properly or not. Okay, so this data set gives you number of passengers who are okay, who are using flights okay, in a year, in a particular year and a month. So this is in 1949 January, there are 112 passengers using a particular carrier. Okay, so again 1949 February, people 118 passengers used flights, so something like that. So this is giving you, so across years and months, how many passengers are traveling. Okay, let us go ahead and do some analysis to see, okay, how the what is the pattern across the months and years. Okay, um, Let me first do flights underscore pivot. First, what we need to do is we need to pivot flight start. Yeah. Okay, this is the data set. Okay, I just want to see, okay, the pattern. So where exactly it has increased, where I have seen huge number of passengers traveling. So this table is good, but the thing is that it is very hard to interpret, hard to find where exactly the values are low and high, right? So like we do in Excel, also we do this heat maps, right? So how do we do the same here in SNS? So once you have the table, so what you need to do is you can simply have, somebody is asking me, is the data set CSV file or not? So this is not the data set. Okay, these are the default data sets present in the SNS library. Okay, we are not importing any CSV file. So SNS.heatmap, then the first argument is this pivot table, whatever I have created. First, let me just directly. So this is the heat map I've got. So if you see wherever, okay, wherever it is high, it is having light color, and wherever it is less, it is having a dark color. Okay, you can see the majority is concentrated along the July and August in the years of 1959 and 1960. It is very easy to interpret now, right? So yeah, these colors are good, but I need the actual values as well. Okay, the way to okay, way to label them is annotation. Annot stands for annotation, and you need to mention that as true. Okay, so you can change format. Okay, so this is how we can actually, okay, create heat maps. Okay, hope this is clear. Okay, let us take a quick break, and okay, let us okay, work on this bank data set. So end-to-end okay, case study. How do we do basic exploratory analysis? How do we create new variables, and how do we build a prediction model? So let us do that after the break. Okay, let's continue our discussion. Let us first import bank data. Let me get the name of the file first. Okay. We need to mention the separator. Okay. Now I have the data. Okay. So if you remember, our use case is this: we need to predict whether a customer is going to accept the term deposit offer from the bank or not. So if he has accepted that offer, then it is yes, otherwise it is no. Okay, so this is a simple prediction problem we are going to implement. So first things first, we need to understand the data. So see here, okay, I have A's column. So total 45,211 entries, non-null count. This is non-null count. So everything is an object. Okay. So everything is an object. So first thing, when it comes to data science, any data science project is all the variables should be integer or numeric variables. Okay. So if you see only age is only day is integer, rest all variables are actually object. When we say object, is nothing but the character variable or string variable. Okay, so it is saying that almost all the variables are character variables. First thing what we need to do is we need to convert everything to integer. So how do we do it? So we need to convert everything into integer using, okay. So first of all, let's see what is the unique values and why are we getting this, or let's say directly we can convert. Okay, so yeah, for I in range. Okay, so what is the range? So if you want to know the shape, bank data dot shape, so it gives you 45,211 rows and 17 columns. Okay, first of all, let me see the sample data also. So A's I can convert it into directly numeric. Okay, so then balance I can convert into numeric. Then what about others? Can I convert duration as campaign as previous as previous as? Okay, so instead of first let me get the columns also. Columns. Let me create a list. Page. Next. Balance. I'm creating a list of columns to convert into numeric. So duration, campaign, periods, yes. Okay, only these are the columns I can convert into numeric, right? Because rest of the columns I can't convert. So I can't convert education into number, right? I can't convert contact into number. I can convert only, even though these are character, okay, this age is an object, okay, this is having numbers in it, right? So that's why we are converting only the variables which are actually numeric but imported as characters. So this is the first thing we are doing. Okay, instead of we have seen for loops and all right before. So let me first print. Sorry, I didn't create. Okay, so it has how many elements? 1, 2, 3, 4, 5, 6. So whenever we are doing something, so first we need to check whether our loop is properly working or not. So it is giving the age, balance, duration, etc. Okay. Now, what do I need to do? Bank data. Now, okay, I have executed the loop. Hope this is working fine. How to check it? Then you need to. So if you see previously, age was object. Now it got converted to numeric, and even balance got converted, and duration, campaign, periods. Okay. So now we have all the numeric variables. So what we can do is we can go ahead and explore the data. Okay. So how do we explore? So we can use all the different visualization techniques we have learned previously. So first of all, let me see the distribution of age. Okay, how to do it? We'll take one variable at a time and we'll see what is the distribution and do we need to keep it as it is, or shall we convert into a different buckets? So what exactly I mean by bucketing, I'll explain you. So first thing is I need to see distribution plot bank data of age. So age, if you see, okay, the distribution is somewhat okay, but when you have lot of outliers, or let's say less frequent ages towards 60, 80, and 100, right? So typically what happens is, in these cases, if we have values like this, instead of having the age as it is, it makes sense to bucketize that. Okay. So what exactly is bucketizing? Let's see. So what we need to do is, okay, we need to bucket age. So for bucketing age, let us build a function first. Age underscore buckets. It will take age. If age less than equal to 30, age bucket into youth age less than equal to, let's say, 50, else, yeah. So this is one way of doing things, but we will not be able to cover some multiple methods, okay, in this just 1 hour. Okay, so I'm just explaining few of the methods. So what you can do is, once you have created these buckets, you can go ahead and see the distribution of yes versus no in these different age buckets. So okay, once I have created, what do I need to do? I need to return is underscore bucket. Okay, so I have created this function. Suppose if I want to create a variable based on this function, so how do I create this? What is the method? We have discussed this previously. Once I have a function, how do I use the function on a particular variable? Is map function, right? So once you have function, you just need to map it. Okay, so let's see how the mapping is done. Now, if you see, we have created AS bucket, elder, middle-aged, etc. Okay. So once we have this, what we can do is, okay, we can see the distribution of yes versus no. So the way to do it is SNS dot outplot x-axis. I want to use this bucket, y-axis. Sorry. Okay, so you can see, so in elderly aged, okay, yeses are very okay. You can see the distribution of yes versus no in the three different buckets, right? You can see more or less. So it is following the same pattern, yes versus no, in all the three different buckets. So this is with respect to age. So this is a good variable. Let's take another variable and see. So, so how the job distribution is there. Shall we keep job as it is, or we need to do something with respect to job? Okay, let's see how the job is distributed. First of all, let's see only counts. Okay, you can see that okay, there are few categories wherein few categories wherein the frequency is very less. Okay, so it doesn't make any sense for okay, any model, okay, wherever okay, if some categories are having very less frequency, so typically what we need to do is we need to club them into a category called others. Otherwise okay, there will be bias in the model. So let us go ahead and do this. First of all, let me see what are the actual data dot job. How do we get value counts? If I want actual numbers, you can see that mostly blue collar are measured in number, then management, technician, etc. And we can see that there are few cases where the numbers are very low. Okay, so what we can do is so whenever count is less than something like okay, we can pick any number and so club all of the categories into one particular bucket. Okay, so what we can do is we can take blue collar, management, technician. Okay, till here this is fine. Otherwise, let's keep this as it is. Okay, so next important concept what we are going to learn is, so all these so we have okay, converted the variables into a numeric, but still we have few variables which are left as character, right? So what we need to do is we need to create them as a dummy variables. There is a concept called dummies. Let us see what exactly is that. Let us take bank data. So bank data underscore new. So whenever we are doing anything, it is always better to take copy. So what is the use of copy function? Anyone? So we have seen three types of copies, right? So one is shallow copy, deep copy, etc. And underscore data underscore new equal to ed dot get dummies. Okay, so you need to mention the dataset name, and columns equal to in the form of list. So what are the columns I need as dummies? I'll mention education, default, contract, rest of the variables are already taken care, and outcome. Then what do I need to do is, okay, I need to, anyway, prefix is not, first let us see this here, contract, there is this contract, it's contact, sorry. Okay, let's see how this data is. If you see what happens, so month underscore June, month underscore March, month underscore May. Okay, so month underscore November. So see, all of these variables are converted to numeric variables. When I say numeric variables, the concept is, so when we say dummies, let me quickly explain you the concept. Okay, suppose let's say I have values A, B, C, D. If this is the original data set, let's say this is the variable I have. If I convert this to dummy, so this is how it will be converted. Okay, instead of x underscore A, x underscore B, x underscore C, x underscore D. So in first observation, you have A, right? Let me increase the size so that you can. So this is nothing but 1, 0, 0, 0. Because the first observation is A, it will say it is 1. If the value is not matching, then it will say 0. So a second observation, the value is B, right? So it should not say 1, it is 0. So here 1, 0, 0. Okay. Here again, this is not A, so this will be 0. This is not B, so this will be 0. This is C, so this will be 1. And this is 0. Okay. Likewise, 0, 0, 0, 1. Okay. So basically ABCD converted to dummy matrix, wherein whenever it is 1, it corresponds to that particular value. So x underscore A, nothing but it says that the value of x is A. Okay, when it is 1, it says the value is A. When it is 0, then value is something else. Okay. So this is how. So we are creating dummies. Okay. So we have converted all the variables into dummies. Then the next important thing to do is, okay, let us go ahead and build a model for this. How do we build a model? Let's see. And before so there is one package. Okay, I need to import. Let me import that. This is a simple end-to-end model we are building. So this is not a comprehensive okay case study. This is a simple model we are building. So are you able to follow everyone? As you know, Python is case sensitive. We need to be extremely careful. Okay, now we have imported a model. Let us, so this is a model we are going to implement. So first equal to, so basically if you remember our OOPS concepts, okay, so these models also follow the same principle. So this is a object we are creating out of this class. Okay, logistic regression. Okay, this class somebody have developed, and you are taking one instance of this particular class. Okay, it has multiple methods in it. So one method is, okay, dot it. Okay, it takes two arguments. One is x and the other one is y. So in order to get x and y, what we need to do is we need to create x and y first. X equal to the variables which we want to use. So let me drop the unwanted variables. How do we do it? So using a drop function. As we have already created dummies for this balance, let's keep it. Housing, let's drop it. So whatever we have created here, okay, let us all use all of them to drop. And axis equal to 1. Distance. Okay. Age, I think need to drop. These are already dropped. Okay, sorry, my bad. Yes, I need to drop because we have is bucket. Next, we need to drop y because y is dependent variable or our predictor variable. I have everything in it. Okay, so this is x-axis and y equal to and now we have x and y. We have something called middle list. Why this is present? Okay, I think we have yes bucket also in this. So as I said, model will not take any strings. Okay, so we need to get rid of these string variables. So let me drop this a bucket also. Okay, I have dropped A's bucket also. Next, it is saying could not convert string to float. No. So where exactly no is present? We need to see that. Okay. So y. So y is present as s and no. Okay, we need to convert that. We need to convert that into s and no. Okay, there are multiple ways of doing that. What we can do is we can simply use np.where. Okay, let me show you how do we use it. So whenever no, then 0, otherwise 1. Now let me see first how the data is looking. Then we can go ahead and use it. Housing. Yes, no. Housing also we need to convert. Yes, no. Let me convert that. Loan also is there. Let me convert loan also. We need to convert all the character variables to numeric variables. Now let's see, do we have anything left? I don't think so. Input contains NaN infinity are too large. So model, whenever we are doing some modeling thing, it should not have any missing values. Okay, missing value imputation, I think we didn't do it. So we need to do the missing value imputation as well. Okay, for the time being, so we can have multiple imputation methods. So one imputation method, let's say, okay, whenever, so I'm just imputing it with 0. You can actually go ahead and impute it with multiple methods. Okay, so now we have model built. Now let's see if I want to check the accuracy of the model. How do I check it? So there is something called, we have multiple functions present in sklearn.metrics. Let us try to use them. Okay, so we need to have predictions. For getting predictions, so see the beauty of classes here. So this particular model object, first we initialize this particular object. Now the model is fitted. Then it knows the values of these fitted values. So once we use predict function present in this object, it has the memory of whatever happened before, right? Because this is how classes and objects will work. If you remember our OOPS concept, okay, so now this particular fit method is executed and it knows the values which are fitted values, and it stores it in the log model object. Okay, now if I want to predict, then the way to do it is, okay, I have the predictions available, I have the original value, that is y, available. Now let me go ahead and okay, print the classification report first. Okay, so if you see, the accuracy is around 76 76%. So there are multiple metrics like precision, recall. Okay, these are all machine learning terminologies, but don't worry about them. You can see the accuracy or F1 score is 89%. That means, so 90% the model is good. It is able to capture the actual information present. Okay, whenever you throw some new data, it will say that whether the out of 100 new observations, let's say out of 100 customers, it will be able to predict for the 90 customers accurately. Okay, so this is the end-to-end pipeline. Okay, so what you need to do, there are so many other steps we can't cover in this 1 hour of class, but anyway, so this is how you generally implement end-to-end okay, machine learning project. Okay, first you look at different variables, try to see, understand their distributions, and see if at all, if you need to impute anything, if you need to okay, change the categorical variable to dummy variables. Okay, all those things you need to do. And finally, whatever you are passing in the model, it has to be numeric. That is the first and foremost rule. Okay. And this is like the basic model we have built. We can actually build a very complex models. Okay, we can fine tune so many things. This is a very crude model I have built. Okay, so many things we can do in this model. Okay, everyone. So if you have any questions, I'll answer. Okay, this is what I wanted to cover today. So tomorrow we'll okay, start with MySQL connections, how to connect to database and how to extract the data, etc. Tomorrow we'll start with MySQL related discussions. Any questions, everyone? So this is just a simple example to show you end-to-end how do we import data and how do we change a few things and how do we build a model. This is not an exhaustive session. Okay. Okay, then if you are good, we can close for the day. Thanks a lot, everyone.